There's this massive misconception that still persists about the cloud.
Oh, yeah.
When people hear AWS, they almost instinctively picture the hardware. These infinite rows of humming server racks, massive hard drives, all the blinking lights.
Right. The giant air-conditioned digital warehouse somewhere in Northern Virginia.
Exactly that. It's a tangible image, but it completely misses the point.
It really does. Because if you actually peel back the layers, AWS isn't just about renting a computer in that warehouse. It's about the logic layer that sits on top of everything.
It's less like a warehouse and more like a massive box of infinite programmable Lego blocks.
And that shift in perspective from renting infrastructure to composing services, that's what really separates, a basic IT admin from a true cloud architect. We're not talking about where the data lives today.
We're talking about how the software behaves.
Precisely.
And that is the mission for this deep dive. We're looking at a very specific and I think crucial slice of the AWS ecosystem that turns all that hardware into actual business value. We're talking developer services, integration tools, business applications, and the Internet of Things.
It's a part of the catalog that, let's be honest, usually looks like a terrifying bowl of acronym soup. SQS, SNS, MQTT, IDEs. It's incredibly dense if you don't already speak the language.
It is. But our goal is to organize that soup. We need to explain not just what these things stand for, but why they actually matter to someone who's trying to build a modern, fault-tolerant business. So we'll look at the tools that sort of glue apps together, the tools that build them, and then the tools that connect them to the real world.
I'm ready. Let's jump in.
Let's do it. I want to start with the concept of the glue. Because before you can even think about a user clicking a button, the different parts of your system have to be able to talk to each other without, crashing the whole thing.
And this is really the whole move from monolithic architecture to microservices. In the old days, software was just one giant block. If the billing code failed, well, the login page failed too.
Everything went down together because it was all tangled up.
Exactly. So the industry moved to decoupling, breaking the app into these tiny independent pieces. But of course, once you break them apart, they stop talking to each other. You need a messenger.
Which brings us to our first major tool, Amazon Event Bridge.
Right.
The source material calls this a serverless event bus. That sounds pretty fancy, so let's unpack what it's actually doing.
Think of Event Bridge as the central nervous system for your entire architecture. In a decoupled system, things happen. We call these events. A user signs up. A payment clears. A sensor detects heat.
Okay.
Event Bridge just ingests that signal and then decides, based on rules you set, who needs to know about it.
So how's that different from just writing code that says, when a user signs up, call the welcome email API?
Because that creates a direct dependency.
Right.
If that email API is down for some reason, your sign-up process breaks. With Event Bridge, the sign-up service just shouts, new user, into the void, and moves on. It doesn't know or care who's listening.
Ah, I see. So Event Bridge is the one that catches that shout and routes it. It decouples the trigger from the action.
It's all about resilience. If the email server is down, the user still gets signed up successfully because the sign-up service already finished its job.
That makes a lot of sense. And looking at the use cases here, it's not just for basic data routing. I see a mention of event-driven security. That seems really powerful.
It's fascinating. Imagine a threat detection service spots a suspicious IP address hitting your server. That's an event.
Right?
EventBridge can instantly route that event to a security function that shuts down access from that IP or isolates a database. There's no human intervention, no paging a sysadmin at 3 a.m. It's just an automated reflex.
That is incredibly fast. So while EventBridge is for routing specific events, sometimes you just need to either blast information out or, hold it because it's coming in too fast.
Which brings us to the classic confusion buster, SNS versus SQS.
Yes. These two are the bread and butter of AWS integration, but I feel like people mix them up constantly.
They do, but the distinction is actually quite clean when you break it down.
Okay, let's draw a hard line then. First, Amazon Simple Notification Service, SNS. The key word here is notification.
SNS is a push mechanism.
Yeah.
The best analogy is a megaphone. You publish a message to an SNS topic, and it immediately pushes that message out to every single subscriber. It's broadcasting.
And those subscribers, they can be other software systems or actual people, right?
Correct. The docs make a distinction between A2A application to application and A2P application to person.
So A2A would be one microservice telling another to, say, update a database. And A2P is a text message.
Exactly that. SMS, texts, emails, mobile push notifications. If you get an alert that your pizza is out for delivery or a security code for two-factor auth, that's almost certainly an A2P notification running through something like SNS.
Okay, SNS is the megaphone. That leaves Amazon's Simple Queue Service, or SQS.
Right, and if SNS is a megaphone, SQS is a waiting room. It stands for Simple Queue Service, and it acts as a buffer.
But why do we even need a buffer in the age of, instant cloud computing? Shouldn't everything just happen immediately?
In a perfect world, maybe. But in the real world, you have what's called back pressure. Let's say you're running a ticket website. A huge artist drops tickets. You get 10 million requests hitting your API in 1 second.
Right. If I try to process all of those at once.
Your database melts, the servers crash, your business is offline. SQS sits in front of those servers. It accepts all 10 million requests, stores them safely in a queue, and lets your back-end servers pull them down one by one at a pace they can actually handle.
It's a speed mismatch buffer. So the incoming data can be super fast, while the processing can be slow and steady.
Precisely. And it's absolutely crucial for reliability. SQS ensures that even if one of your processing servers crashes, the message isn't lost. It just sits there in the queue until a new server comes online to pick it up. It prevents data loss during huge traffic spikes.
Okay, that makes sense. It's about not dropping the ball when things get chaotic.
Right, so we've got the glue. Now we need to talk about how developers actually build these systems. We're moving into the workshop, the developer tools.
This section of the notes is just dominated by the code family of services. It feels like AWS just stuck the word code in front of every single stage of the software lifecycle.
They pretty much did. And it's all designed to replicate what a developer might do on their laptop, but in a secure, managed cloud environment. It's an assembly line.
Okay, let's walk through that assembly line. It all starts with writing and storing code. That's AWS Code Commit.
This is your source control. It's basically a managed private Git repository. If you've ever used GitHub or GitLab, you know exactly what this is. The main difference is that it's integrated tightly with AWS security.
So you don't need separate logins or anything?
Nope. Then you need to turn that raw code into actual software. That's AWS Code Build.
The compiler.
Right. It spins up a server, downloads your code, runs all your tests to make sure you didn't break anything, compiles it, and then shuts down. You only pay by the minute.
Which is way better than keeping a dedicated build server running 24/7. So once the code's built, where does it go? The notes have AWS Code Artifact next.
Code Artifact is for your dependencies. Modern software isn't written from scratch, right? It relies on all these libraries and packages. Code Artifact is a secure vault for those packages, so your company isn't relying on public repositories that could go down or even get compromised.
And finally, getting the app onto the servers. AWS Code Deploy.
Code Deploy automates the release.
Yeah.
It pushes the new software out to your EC2 instances, your Lambda functions, even your on-premise servers. It handles the tricky stuff like rolling updates, so the application never actually goes offline during the update.
And the thing managing this whole assembly line is AWS Code Pipeline.
The manager, yeah. That's your CI/CD, continuous integration, and continuous delivery. Code Pipeline watches your source code. The moment you save a change, it automatically triggers the build, runs the tests, and deploys the app. It automates that whole path from idea to production.
Now, I did see a little flag in the research on something called AWS CodeStar. It's marked as deprecated.
Yes, that is a really important call-out. CodeStar was an attempt to sort of wrap all these tools into a single dashboard for rapid setup. But it seems AWS is pivoting away from it now, probably encouraging developers to use more robust setups. Long story short, if you're starting a new project today, just skip CodeStar.
Good to know. So even with all this automation, things still break. And in a distributed system with EventBridge and SQS and all these microservices, finding the bug seems impossible.
It's the nightmare of microservices, and that is exactly why AWS X-Ray exists.
I love the name. It just implies visibility.
And it provides exactly that, through distributed tracing. It tags a user request with a unique ID as soon as it enters your system. Then, as that request bounces from the load balancer to the API, to the database, to SQS, X-Ray tracks it every step of the way.
So instead of just seeing some generic timeout error, you actually see a map of the request's journey.
You see a map that literally says the request took 20 milliseconds here, 50 here, and then it hung for 3 seconds at the database.
Yeah.
It just visualizes the bottleneck for you instantly.
That seems absolutely essential for performance tuning. And speaking of tools, we should also talk about where you write the code. It seems like the cloud is coming for the laptop itself.
You're talking about AWS Cloud 9. It's a full cloud-based IDE, an integrated development environment.
That just runs in your browser.
It does, which solves that classic, well, it works on my machine problem, because your development environment is now identical to the cloud environment. Plus, and this is cool, it enables real-time collaboration.
Like Google Docs for coding.
Exactly like that. Two developers can be in the same file, editing at the same time, with a little chat window on the side. It's fantastic for remote pair programming.
That is cool. And for later tasks, there's also Cloud Shell.
Yeah, Cloud Shell is just a browser-based command line. It's pre-authenticated, so if you just need to run a quick AWS CLI command to check on a resource, you just pop it open, do your work, and close it. You even get a gigabyte of persistent storage.
Before we leave the workshop, there's one more tool that I think is strategically underappreciated. AWS App Config.
Ah, feature flags. Yes.
Explain this. Why is separating your configuration from your code so important?
Well, traditional deployment is risky. You want to launch a new feature, so you deploy new code. If it breaks, you have to do a rollback, which is messy and stressful and causes downtime.
And App Config changes that.
With App Config, you deploy the code, but you hide the new feature behind a flag that's turned off. Then, using the App Config console, you can turn that flag on for just, say, 1% of your users.
A canary release.
Right. You watch the metrics. If the 1% are fine, you ramp it up to 10%, then 50, then 100. If errors start spiking, you just flip the switch back in App Config, and the feature turns off instantly. No redeployment needed. It turns a deployment into a non-event.
It separates the deployment moving the bits from the release users actually seeing the feature. That's a very mature way to build software.
It's how the big companies do it. App Config just makes it accessible to everyone.
Okay, so we've built the backend, we have our tools. Now let's move out to the edge. This is section 3, mobile, front-end, and IoT. This is where the code meets the user.
Or the device.
Let's start with web and mobile developers. The notes highlight AWS Amplify. It's described as the fast lane.
Amplify is what we'd call an opinionated set of tools. It's really designed for front-end developers, people working in React or iOS, who just don't want to spend weeks configuring IAM roles and database tables.
It abstracts the backend away.
Heavily. You can basically tell Amplify, I need a login screen and a place to store photos, and it will provision all the underlying AWS services, like Cognito and S3, for you automatically.
And pairing with that is something called AWS AppSync.
AppSync is the data layer for these kinds of apps, and it's usually powered by GraphQL.
I see GraphQL everywhere now. How is it different from a standard REST API?
With a standard API, you might have to make 3 separate calls to get a user's name, their last order, and their preferences. That's slow, especially on a mobile network. With GraphQL and AppSync, you send one specific query asking for exactly what you need, and you get it all back in a single shot.
So it just reduces the network chatter?
Significantly. And it also handles things like offline data synchronization, which is notoriously hard to build yourself.
Okay, now let's go even further out. Beyond the phone to the Internet of Things.
IoT. This is where the cloud actually touches the physical world. Factory sensors, agricultural monitors, smart coffee machines.
The entry point here is AWS IoT Core.
IoT Core is the connector. It's what allows, potentially, billions of devices to maintain a persistent connection back to AWS.
The source notes highlight the use of the MQTT protocol. Why not just use HTTP like a web browser?
It's all about overhead. If you've got a tiny temperature sensor running on a watch battery out in a cornfield, waking up a full HTTP connection would just burn too much power and data. MQTT is incredibly lightweight. It's designed for spotty networks and very low power consumption.
But here's the problem. Sometimes the internet just cuts out. Or maybe you need a decision made faster than the time it takes to send data to Virginia and back.
That's the latency problem, and the solution is AWS IoT Greengrass.
Greengrass. It sounds like a landscaping company, but this seems way more complex.
It's arguably one of the most futuristic services in the whole stack. Greengrass basically installs a little piece of software on your physical device, a camera, a gateway, a robot, and it lets that device run AWS Lambda functions locally.
So the processing happens right there on the metal, not in the cloud.
Exactly. Take a security camera. Instead of streaming 247 HD video to the cloud, which would cost a fortune in bandwidth, Greengrass lets you run a machine learning model on the camera to detect a person.
And it only sends data when it actually finds something.
It sends the alert to the cloud. The heavy lifting is done at the edge. The coordination is done in the cloud. It saves a ton of money. It works offline. And the reaction time is instantaneous.
Brains on the edge. I like that. Okay, we've covered the tech stack. Let's talk about the business side because eventually humans have to use this stuff. This is section 4, the human element.
Right. Communication, desktop virtualization, and, just getting support.
Let's start with the contact center, Amazon Connect.
This is a fascinating one because it's the exact same software that Amazon uses for its own massive customer service operation. It's a cloud-based contact center you can spin up in minutes.
But it's not just a phone bank. The AI integration seems to be the real key here.
It is. It uses sentiment analysis. So as a customer is talking, the AI is analyzing their tone. Are they getting angry? Are they frustrated?
And it can route the call based on that.
This customer sounds furious. Route them immediately to a senior supervisor. It also gives the agent a real-time transcript and suggests answers. It turns the contact center into a data stream.
Then there's Amazon SES, simple email service.
The workhorse.
Yeah.
If you need to send 10 million marketing emails or transactional receipts, you don't use your personal Gmail, you use SES. It's built for scale and high deliverability.
What about when the office itself is in the cloud? We have Amazon Workspaces and AppStream 2.0. They sound similar.
They solve the remote work problem from different angles. Amazon Workspaces is a full virtual desktop, a VDI.
A whole computer in the cloud.
Yes. You log in from your iPad or a cheap laptop and you see a high-power Windows desktop. Your files, your wallpaper, it's all there, persistent.
The notes mention pools versus personal.
Personal is your computer. It remembers you. Pools are non-persistent. Think of a call center shift or a university lab where you just need a fresh desktop for a few hours and then it gets wiped clean for the next user.
So how is AppStream 2.0 different then?
AppStream doesn't give you the whole desktop. It just streams a single application.
Right.
Let's say you have engineers who need to use heavy 3D CAD software, but they're working from home on MacBook Airs.
Which can't run that software.
Right. But AppStream runs the CAD software on a powerful server in AWS and just streams the window to the MacBook's browser. The engineer feels like they're running it locally, but the data never actually leaves the secure cloud.
That is huge for security. No intellectual property ever sits on an employee's laptop.
Exactly.
Finally, how do businesses get help building all this stuff? There are a few programs mentioned.
For startups, there's AWS Activate. It's basically a scholarship program. Free credits, sometimes up to $100,000, and technical support to get you going.
Then there's AWS IQ.
A freelance marketplace for certified experts.
Mm-hmm.
However, and this is why we read the fine print, the source material is very clear that AWS IQ is ending support soon.
So if you're planning your strategy for a couple of years from now, don't build it around AWS IQ.
Correct. It's likely being phased out for other partner networks.
And lastly, for the big enterprises who just want the problem to go away, there's AWS Managed Services, or AMS.
AMS is the easy button for operations. You're basically telling AWS, you patch the servers, you handle the backups, you monitor the security. It lets your internal team focus on building new features instead of just keeping the lights on.
So if we look back at the map we've drawn, we have the plumbing event bridge and SQS keeping data flowing. We have the workshop code pipeline and Cloud9 building the apps, the edge IoT Greengrass sensing the world, and the human layer connect and workspaces running the actual business.
It's a really comprehensive ecosystem. But I think the takeaway isn't just the breadth of it all, it's the shift in philosophy.
How do you mean?
All of these tools, Amplify, AppCan, Fig, EventBridge, they're all designed to maximize agility. In the old world, testing a new business idea took, 6 months of hardware procurement? Today, you can spin up a global contact center, a decoupled backend, and an AI-driven front end in a single weekend.
The barrier to entry has just collapsed.
And so has the cost of failure. If the idea doesn't work, you just turn the services off. You aren't stuck with a server room full of depreciating assets.
Which brings me to a thought I've been mulling over. We talked about IoT Greengrass moving processing to the edge, and tools like Amplify that abstract away the entire backend.
I think I see where you're going with this.
It feels like we are moving toward a future where the cloud itself becomes, invisible to the developer. You don't think about servers, you don't think about queues or databases, you just write pure business logic.
That's the serverless dream. As these abstractions get better and better, the developer stops being a part-time infrastructure engineer and becomes purely a creator. The cloud becomes a utility like electricity. You just plug your code in and it runs, scaling infinitely without you having to turn a single dial.
We're not quite there yet, but with tools like these, it feels like we're getting closer every single day.
It's a fascinating trajectory to watch.
Well, that's a wrap for this deep dive. We have covered a lot of ground. Whether you need a megaphone like SNS, a waiting room like SQS, or a brain on the edge like Greengrass, there's a block in the box for you. Thanks for listening.
See you next time.